same place. Interactions between the Earth's surface and its interior have landed Virginia where it is today. 400 million years ago, Earth's supercontinents were on a collision course with one another. Forces beneath the Earth's surface were driving the movement of these large continental plates. Let's take a closer look at these forces in action. Around 350 million years ago, the oceanic crust of the African plate slid beneath North America's continental crust in a process called subduction. Subduction occurs when two plates collide and the edge of one dives beneath the other. This process allows continents to move towards each other by consuming the intervening ocean crust. At about 280 million years ago, Africa plowed into North America, merging into a supercontinent called Pangaea and forming a collision zone. Both plates resist subduction, and over millions of years, they buckle and are forced upwards to create mountains, like the Appalachians. By 230 million years ago, Pangaea began to break apart in the process called rifting. Rifting occurs when a continent literally fractures apart, forming a valley, then a narrow sea, and eventually an ocean. Magma rises into the fracture, forming the crust beneath the new ocean. After Pangaea broke apart, North America and Eurasia were separated from Africa by the growing Atlantic Ocean. North America and Europe then rifted apart, and the continents drifted into their present orientation. Continental drift isn't just a thing of the past. Even today, all around us, there is rifting, subduction, and collision taking place on our dynamic, living planet that we call Earth.
The heart of the Earth, its inner core, is a solid ball of iron and nickel. Here the pressure is so high it never melts, despite the intense heat of 3,700 degrees Celsius. The outer core is under less pressure, so it is molten. This is enclosed by a deep layer of hot rocks called silicates. This is the mantle, and it's 3,000 kilometers thick. The surface is hard and forms a solid crust. If the Earth was a peach, this crust would be as thin as its skin. The Earth's crust is cracked and brittle. like an eggshell. It's made up of several segments called tectonic plates. There are two kinds of crust. Continental crust forms the great landmasses of the world. This is thick. These rocks are made of ancient lightweight substances like granite. Some were formed almost 4,000 million years ago. Oceanic crust, which lies under the planet's great oceans, is much thinner. Oceanic rocks like basalt are heavy and much younger, 1/20th the age of continental rock. The plates float on the dense mantle. Scientists believe that the immense energy of the Earth's inner heat sets up convection currents in these rocks, which move the crustal plates about, but very, very slowly. Some are moving apart. Some move towards each other. Other plates just slide past one another. These movements in our planet's crustal plates have created some of the most dramatic features of our world. This is the highest mountain range in the world, and it's getting higher all the time. Every year, Mount Everest grows by 1 centimetre. These mountains are caused by the collision of two plates of continental crust. They're called fold mountains because the layers of different rocks within the Earth's crust, the strata, are folded and bent. Over time, erosion of the layers can occur at different rates, producing characteristic jagged rock